Hi everybody, I'm going to share our paper to you. Cross-modal information flow in multimodal large language model. So for this project, we aim to investigate the inner working mechanism of the multimodal large language model when it performs multimodal tasks. So we are going to say within the autoregressive multimodal large language model, where is the visual and linguistic information integrated, and how is the visual and linguistic information integrated, and how is the final prediction generated? So this is a very popular architecture of the multimodal large language model, LLaVA. So in here, there is a large language model, and before that, the image is encoded by a large vision encoder, and they are encoded into several image patch embedding. And this embedding are contact with the word embedding and the last token embedding. And then they are input into the model, and the answer is generated from the last token. So first of all, for our project, we collect 6 different VQA tasks. They are different in the structure and the semantic. So maybe for some question they have the option, but some question they don't have. And some question they target ask about the category of the object, or they also target ask about like the relationship between the objects in the image. And the method we use is attention clock, because we are going to say the interaction between different tokens. So for a transform-based architecture, the only module that allows the interaction between different tokens is the attention. So in the attention module, we did some engineer reverse thing to say the information flow. For example, this is one layer of the transformer, and the input is the image and the question and the last token prompt. And this means that the correct answer, and P1 is the probability of this correct answer. And if you are going to say the information between the image and last token, we only need to block the attention age between the image and the last token, and then we can get a probability 2 for the correct answer. And then we can calculate the relative change in the probability. And we can use this change to quantize the information flow between the image and the last token. The same thing if we're going to say the information flow between the image and the question, we only need to block the attention age between the image and the question tokens. Step by step, because it's a decoder-only architecture, and then we can also get the P2, and we can also calculate the relative change in the probability, and we use this change to evaluate the information flow between the image and the question. And we can say the result now. First of all, we are going to say the information flow between the different part of the input to the last token. And there are 6 sub-figures. For each figure represent one weekly task. And the x-axis means the layer because we block the attention age for each layer separately. And then the y-axis is a change in the probability. So when the probability change, that means there are information flow separate. To be specific, we can say here there are 3 lines, means we blocked token, different input token to the last token. For now, we can focus on these 2, the green one and the yellow one. The yellow one means I block the attention age between the image token and the last token. And for most of the tasks, there are no change for the yellow line. And the green one is I block the attention age between the question and the last token. And we can obviously say that there are a large decrease for the probability. That means there are information flow from the question to the last token, and they occur around the second 20 layers. So for now, we know the question will directly transfer the information to last token, but we question, like this is a multimodal task, but why the image didn't contribute to the final prediction? So we guess maybe the image contribute to the final prediction in an indirect way. So we conduct the second experiment. We block the attention age between the image and the question, and we can find that there are 2 times probability drop. So first drop is in the 0 to 4 layer, and the second drop is around the 10 layer. And even for these two, the second drop is very slight, but there's occur position is similar. It's also in the around the 10 layer. So that means the information flow from the image to question. There are 2 times. First is in the 0 to 4 layer, and second is in around the 10 layer. So from now on, we can make a small conclusion. When a multimodal large language model doing a multimodal task, in low layer, the image transfer information to the question 2 times. One is in the 0 to 4 layer, and second is around 10 layer. And then in higher layer, like around 20th layer, the question already gets the image information, and then the representation in the question position, they transfer this kind of multimodal information into the last token for the final prediction. So next, we are going to say, because we say there are 2 times probability drop, we are going to say what's the difference between these 2 information flow between the image to the question. So we separate the image into 2 image patches into 2 groups. So first group that contain all the object patch, because our question target the object. So we call this group is a related image patch. And the second group is the remaining patch. That is, we call it other image patch. So we do the same thing with the previous slide. We block attention age between these two different image patch group and the question separately. And we say there's a change in the probability. The result is in here. We can know there are two different lines. The pink line means we block the attention age between the other image patch and the question. And the green one means that I block the attention age between the related image patch and the question. And we can find during the 0 to 4 layer, the pink one play a dominant role, but around the 10 layer, the green one play a dominant role. But when we add these two lines together, it's kind of just like this line. This line is the information flow from the whole image to the question. And this figure is we block different parts of the image attend to the question. So that means the model in the low layer, they kind of only transfer the whole image information to the question, and the higher layer only the related image patch transfer information to the question. And we also trying to track the probability of the hidden representation at the last token across different layers. For the answer word, there are two kinds of answer word. So first answer word is that the all letter is lowercase, and the second answer word that like they have the capital initial letter. So we can say like in here in the second in the 20th layer, the red one gets sharply increase. That means in here the model already knows the answer. It is the answer word with lowercase for all letter. But with the increase of the layer, this probability decrease, and at the same time, the blue one increase. Blue one is the answer word with the capital initial letter. So that means the model at the 20 layer, the model will know the answer semantically because they know the all letter with the lowercase. And with the increase of layer, the model is doing something like the grammar thing or syntactic thing. They're trying to transfer the initial letter from the lowercase to uppercase. So conclusion. When a multimodal large language model performing the multimodal task, they input the image and the question and the last token. In the low layer, the model transfer the whole image information to the representation of the question. and then only the related image patch information transfer the information to the representation of the question. And then at this time, this representation already being a multimodal information, and this multimodal information is transferred to the last token, and then the last token will get know what its answer is, and then in higher layer the model trying to transfer the initial letter from the lowercase to uppercase. Yeah, this is our project. I hope you will like it. Thank you for your listening.